Hi there, and welcome back to Greatest Common Factor and Lowest Common Multiple review. This is my very fancy setup, just to review things that we learned before the winter break. If you remember, we're talking about factors. So factors are numbers that go into another number. We're going to be using the numbers 20 and 36 as the example, and we want to find the greatest common factor of 20 and 36. So if you were just as a review, greatest meaning the biggest number that goes into both of these 20 and 36. So the first method is the list method here, and this is what I said was easier, but later on we're going to be using factor tree method in school, so you should learn that as well. So just to review the list method, you just write both numbers like this, and then you list the factors. Remember, for list method, you want to use the divisibility rules to find what numbers go into 20. So in our divisibility rules, for example, I told you it would be helpful if you print those out. You know that 1 always goes into a number, so 1 is always going to be a factor. You know that 20 is also going to always be a factor of 20 because it is the number itself. The next one is 2. Does 2 go into 20? Well, the divisibility rule for 2 is if 20 is an even number, then yes, it's divisible. So 20 is an even number, so that means 2 is a factor. Our divisibility rule for 3 is if you add those digits together, in other words, 2 plus 0, if that sum, meaning 2 plus 0 equals 2, if that was divisible by 3, then 20 is divisible by 3. 2 is obviously not divisible by 3, so 3 is not a factor. So we could just cross out 3. It's not a factor. 4, we know that 4 times 5 is 20. You can check a multiplication chart. The divisibility rule for 4 is really the last 2 digits are divisible by 4, and there's only 2 digits here, so it's not really applicable. And we know that 4's factor pair for 20 is 5. Since 4 and 5 are right next to each other, we're done using the divisibility rules, and now we just need to find the factor pairs. So if you remember, factor pairs are numbers that when multiplied together give you that number. So 4 times 5 is 20. They're right next to each other. We're done. Let's find the rest of them by using the factor pairs. So 2 times what number gives us 20? That would be 10. And since 1, we already know the factor pair for 1 is 20, then we're done. We're done finding all the factors for 20. Let's do the same method to find the factors for 36, starting with 1, of course, followed by 2, because 36 is an even number. 3, this is where we can use the divisibility rules for 3. 3 plus 6 is 9. So if you didn't know that 36 was divisible by 3, you know that 9 is. So that means 3 is a factor of 36. 4, last 2 digits, are divisible by 4. And we know that 4's factor pair is 9. So let's just write it over there for now. 5 we know is not a factor of 36 because 36 does not end in 5 or 0. 6, our divisibility rule for 6 is that 2 and 3 are already there, so we know that 6 is. And we know that 6's factor pair is 6 because 36 is a perfect square. So we're done again with our divisibility rules, and we can go on now to end our process by finding the factor pairs. So 6's factor pair is itself. 4's factor pair is 9. Beautiful. 3's factor pair is 12. 2's factor pair is 18. And 1's factor pair is 36. In other words, 1 times 36 is 36. 2 times 18 is 36. 3 times 12, 4 times 9, 6 times 6. Now all we need to do is we found all of the factors that go into 20 and 36. Now we just need to find what is common as well as the biggest. So if we start from the right side, let's see what is the biggest number that goes into both 20 and 36. 36 is a factor of 36, but is not a factor of 20. So let's just go down the list until we find a number that's the biggest. So it looks like the biggest number that's common for both 20 and 36 is 4. Your final answer then for GCF is 4. So list method, super simple. Just list all the factors for each number using your divisibility rules and factor pairs, and then find the biggest that's common. The factor tree method, let's review it again, is you need to draw a factor tree for 20 and 36. When you find the factor tree for 20 and 36, let's start with 20. It's very simple. All you need to do is find a factor pair. Any factor pair will do. In other words, 4 times 5 is 20. Let's continue because 4 is not finished. It's a composite number, which means it can be broken down further. Let's do 4 into 2 times 2. And 5 is already a prime number, so we'll just bring it down like that. So once again, write the number at the top, break it down into any factor pair. I could have done 2 times 10. I could have done 1 times 20, which is kind of useless. I could have done 5 times 4 or 4 times 5. I did 4 times 5, and I had to break down 4 further. Now, because 2, 2, and 5 are all composite numbers, I'm done my factor tree. This is called prime factoring. Let's go on to 36. 36, let me think of a factor pair for 36. Well, we could just do 4 times 9. Both of these numbers are composite numbers, meaning they can be broken down further. So 4 can be broken down to 2 times 2. 9 can be broken down to 3 times 3. And these are all prime numbers, so we're done. Now this is the part where students get a little bit confused. When I look at 2 of the trees, all I need to do is pair up the ones that are common. So there's a 2 here and there's a 2 here. There's a 2 here and there's a 2 here. There's no 5 in this one, so it's not common. There's no 3 in there. There's no 3. So only the 2 and the 2. After that, it's just a simple case of multiplying these two numbers together. So here, the GCF is 2 times 2, or 4. Notice how we get the same GCF here as we do here. These are just 2 different methods of finding the same answer. Okay, so that one is GCF, greatest common factor. Watch this video a couple times so that you can get it, understand how it works, and then practice with the practice questions.